The starting point for SIL verification calculations is characterization of the failure characteristics of the devices that are part of the safety instrumented function. That means we need failure rate data. Failure rate data in Vertigo is classified based on something that we call instrument types, because in any particular plant or process facility, there might be multiple sensors that are all of the same type, meaning all of the same make and model, and therefore they would all have the same failure characteristics. So the lowest level starting point in our database structure is an equipment type. Now, to view the equipment types that are available in a particular study, you go to the View button on the navigation bar, and then you'll see that in the middle of the View button you can view the different types that are available. So let me just click on Process Connections, and when I do that, you'll come to a page that is going to list equipment types, and you'll see that we have choices for process connections, sensor interfaces, sensor types, logic solver types, final element interfaces, and final elements. And when we define the failure characteristics, the definitions occur in essentially the same way regardless of the type of equipment item that it is. So let me just bring up the sensor types. So these are the sensor types that are available in this particular study. And you'll notice, let me just go ahead and pull one of these items up to show you some of the information that's available for each particular type of instrument. That's going to include an overall failure rate, including all modes of failure, then a safe failure percentage. That is it's not the safe failure fraction because it doesn't include diagnostics. It's just inherently what percentage of the failures are to the safe mode, and then the opposite, inverse of that, or the complement of that would be what are the percentage that are dangerous. So we input the percentage that are safe, and then we have coverage factors for diagnostics. There is a safe coverage factor and a dangerous coverage factor. From those four items, the different failure rates are calculated. So lambda DU, dangerous undetected, lambda DD, lambda dangerous detected, lambda SU, safe undetected, and lambda SD, safe undetected and safe detected. So those are the items that are going to go into the failure rate calculations. There are also places that you could put in information about a data reference, where the data came from, essentially, any database revisions that the data came from, and then also an architectural constraint type. So what type of device is it? A type A device or a type B device as defined in the IEC 61508 standard. So that's the type of information that's available on all the components. And for each different component, we can define it several different ways. We can define our individual components by gathering data from a library. We can custom input the definition of the device for a specific project. We can create a black box model that has direct information about the PFD and the spurious trip rate instead of running calculations. And we can also create a type of black box model where we link the failure rate parameters to arbor fault trees. And we'll get into all of those different methodologies in the coming sections.